Welcome to Pure One, Chapter 9. In this chapter, we are looking into SOHCAHTOA trigonometric ratios again. So in this chapter, hopefully if you have done your GCSE properly, you would have found nothing really new in this chapter, apart from maybe in the maybe 9.6, a bit more from 9.6, but that's only marginal because we're just combining chapter 4 about transformation into graphs. But so what's the purpose of this chapter? The purpose is that this is setting you up for chapter 10, which is in something a bit more advanced in trig ratio that you will have to learn. So in this lesson, we are looking into cosine rule and sine rule. Again, you should have known them, you should have remembered them, you should have learned them. So, um, in this lesson, you can actually use all the examples as a practice question if you would like to. You can actually literally do them all and then try it yourself and then check your answer if you got right or wrong. Again, there's nothing really new in that case. Right. If there's anything new, I would say is try to do some maybe A-level style question on cosine rule, sine rule. But other than that, the knowledge is essentially the same as GCSE. So cosine rule. What's that? A squared equals B squared plus C squared minus 2BC times cos A. So remember the A is the angle opposite to the length A. When do we use it? When we see a triangle that involve all three lengths with an angle, then that's when we use cosine rule. All three lengths with an angle. Now, some of you might remember from your teacher in GCSE asked you to rearrange A squared minus B squared. Was it A? I can't remember that. Was it what was the formula they gave you that? Was it B squared plus C squared minus 2 minus A squared over 2BC perhaps? Something like that, just to make cos A the subject, forget about that. We've got too many important things that we have to remember in life. This formula is not one of them. For example, you have to remember to wash your clothes. You have to remember to feed your dog. You have to remember what you want to eat tonight. You have to remember you have to buy groceries. You have to remember mom asked you to tidy up your bedroom or dad asked you to put away your PlayStation. There are too many of these little important things, especially your friend's birthday. When are they? These two important things that we have to remember. This formula becomes, just a piece of salt, a grain of salt. See, English not important as well. Why do we have to learn words? Anyway, the A value is the length opposite angle A. We'll talk about that. So, example, missing length. Calculate length of the side AB in a triangle ABC in which AC, BC, and ACB equals 100. So we can easily draw a triangle out. It doesn't matter if you're right or wrong. It looks like right or wrong. It doesn't matter. We just want to see visually where they are. Where are they? So AB is 8.7. AC is 6.5. Clearly, you can tell already I drew the triangle wrong because AB should be longer than AC, but doesn't matter. ACB equals 100 degree. That looks really off. Okay, so that's obtuse angle. Okay, so let's try again. Right, life's so difficult. Right, no, just kidding. Drawing triangles is way too difficult for me. 100 degrees, something like this, maybe. Okay, so 100 degrees. So this little B. Ah, okay. This little B go here, and then C is here. So AB is 8.7. Oh, I mean, BC is 8.7. This length has to be longer. Okay. All right. We need to say the question happy. AC is 6.5, BC is 8.7. Go up. There. Right, ask the question happy. All right, finally. Okay. So then we'll work out length AB. Okay, so clearly you can tell that's your A, that's your B, and that's your C. So we can use the cosine rule. So A squared equals B squared plus C squared minus 2BC cos A. Now, personal preference, when I have used cosine rule or sine rule, I always write out the formula once first, because then that way I can just fit in a number, substitute in the algebra correspondingly without recalling the formula together. It's like you doing one thing at a time rather than processing two things in one time. Because if you try to substitute and recalling the formula at the same time, then you're more prone to make mistake. So that's why you should write the formula out. So A squared, A is unknown. B squared is 6.5 squared plus C squared is 8.7 squared minus 2 times B times C times cos A. Now, if you have lent your calculator to your brother or the sister who is in year 13, or that they may have used radians before in a calculator, be careful. So if you have no idea what I'm talking about, if you go on a calculator on the display, On the top, it should say you should see letter D instead of an R. Let me show you that. Give me a sec. So for example, in here you can see my calculus plate on top, it says R, which is wrong, which is radians. You want degrees because the angle, well, if you don't know what radian is, radian essentially is an alternative unit to an angle. You have degrees, you have also radian. Degrees what you've learned so far. Radian is something you haven't learned yet. Okay. So, but if you have an older sibling might have used radian before, just be careful. So R. So to change that, make sure you press shift menu. Okay. So shift menu, you want to go and set up. The yellow one means shift and then press the menu button and then angle unit. And then you see I can choose, oh, there's a gradient, whatever that is. I don't know this. Degree. So we use degree. Now you can see at top, it means refers back to D. Okay. So if you put in a calculator 6.5 squared plus 8.7 squared minus 2 times 6.5 times 8.7 times cos 100 degree, you get 137.558. Now let me show you what if it's a radians. Okay, if it's a radian, okay, I do the whole math again, press equal. You see it's 20.4. Looks legitimate value. However, it's a wrong answer. So we want an answer back to degree. So 137.58. Okay. Right. So a squared equals 137 point, what was it again? 58. Sorry, goldfish memory. Told you these numbers are not worth remembering. Not important. So square root that, you get 11.73 centimeter. Easy peasy. Next one, right? Mixed angle. So find the size of a smallest angle of a triangle whose sides has 4, 7, and 9. Okay. 4, a bit longer, and maybe a bit longer as well. Oh, it looks like, oh, whatever. Okay. 4, 7, and 9. So smallest angle. Now the smallest angle must be opposite to the smallest length. If you don't know that. Okay, smallest angle must be opposite to smallest length. 4 is the smallest length, therefore this is smallest angle. Let's call it theta. Okay, so which one's the biggest which angle is the biggest one? It's the one opposite to the longest length, 9. Okay, and that's why if you think about in a right angle triangle, why is the hypotenuse the longest? Because in a right angle triangle, if that's a 90 degree, that means these two angles must be acute angle and must be smaller than 90 degree. Therefore, the 90 degree is the biggest angle in the whole triangle, and therefore the length opposite to it must be the longest, aka the hypotenuse in this case. Right? Anyway, so the smallest angle is the one opposite to the smallest length, 4. So again, a square, because three lengths with an angle, that means I need to use cosine rule. Right? So a squared, so a must be 4. So a must be 4, so that must be a, b, and c. Right, so a squared is 4 squared equals b squared, 7 squared plus c squared minus 2 times b times c times cos theta. So what I'll do is put in a calculator. So 16 equals 49, or use your mental maths. Like my mental maths, really good. Minus 2 times 7 times 9. Oh, calculator, please. 14 times 9 is, or mental maths, 126. Of course I know. 126 cos theta. So be careful. This one is the term. This one is the term with the cos theta, so you can't simplify with the other numbers. So what I'll do is I bring all the numbers to the left hand side. So 16 minus 49 minus 81 will give me 114. So negative 114 equals negative 126 cos theta. Divide both sides by negative 126. So minus 114 over minus 126 equals cos theta. I don't like cos theta in the right hand side, so I'm going to just flip them around and then put in a calculator. Inverse cos of 114 over 126. By the way, inverse cos, sometimes I might say arc cos. Now, arc cos is the proper mathematical name for the inverse cos. Okay, so there's arc sine as well. So this is the proper name to call it mathematically. You can call it inverse cos, but that's not the technical mathematical name. It's called arc cos, arc sine, arc tan. Okay, so anyway, put in a calculator, you should get 25.2 degree. Right? Again, just to show you the difference in gradient and I say gradient. No, I don't mean gradient. I mean radians. So let me put that. Okay, so inverse cos or arc cos of 114 over 126, you get 25.2, which is the correct answer. But if you put in radians, you see an R in there, equal again, you get 0.45. That's obviously that's a wrong angle. You can't have such a small angle, not in degree term. You can have such a small angle in terms of values, but you can't have zero point 0.4. You can have 0.5 degree, I guess. When you talk about maybe something smaller like a turn or something, turning in zero point 0.5 degree when you talk about driving a cruise or something. Anyway, so that's the answer 25.2. All right. So I feel like I've been dwelling for too long on this one. So pause the video, have a go and practice question one anymore. Practice question two as well if you prefer. Okay. So one by one, I'll give you the answer of question one and then move on to question two. So pause the video, have a go at question one. When you're ready for the answer, you can press play. So here's the final answer. First of all, draw a triangle out, and we're given the angle ABC is 60 degree. Therefore, the length opposite to 60 degree, which is given, will have to be our A value. So A squared will have to be 5 squared. Okay, if you got wrong somewhere from the beginning, from get-go, again, pause video, finish it off, and then come back to it. Now, the algebra is slightly trickier in here. That's why it's an A-level question in here. So first of all, was subject incorrectly, what you should realize is you've got x plus 2 as a bracket squared, expand double bracket, you should get x squared plus 4x plus 4. Then in here, it looks a bit clunky, the 2bc cos A thing. First of all, don't forget, cos 60 degree, put in a calculator, you should get a half. So what I've done in here is 2 times b times c, I times 2 and 2 and x together, give you 2x. Now, then what I've done in here from this step to this step is I expand the bracket numerator. In the top, 2x times x is 2x squared. 2x times 2 is 4x. Okay, now I keep the bracket because there's a minus on the outside. And then cos 60 degree is a half. So means times a half means over 2. So that's where the over 2 come from. And then what about from this step to this step here? What have we done? Now, the 2 over 2 means we can cancel out the 2, divide everything by 2, give it 2x. But the minus on the bracket, outside bracket, means you have to change the sign inside the bracket as well. So minus a plus makes a minus. Minus a plus makes a minus. That's why it's minus x squared minus 2x. Once we got to that stage, then you should simplify the algebra. You should realize it's a quadratic. In a quadratic, you can use a calculator to, so if you don't know where it is, to solve the equation, you can go with this type equation function. If you calculate a newer model or slightly different, the A-level calculator will always have this function just hidden somewhere, but it should say equation and function. And then polynomial, degree is 2 because of quadratic. So you put it 1, 2, and minus 21. Okay. And then, yeah, that's 3.69 and equal again is 5.69. If you don't know where to get this from, if you want to know more, you can go back to chapter 2 video, which I've gone through a lot more quadratic things in chapter 2. Right. Next. Okay. Press question 2. Again, pause the video, have a go at the question. Okay. Or you're unsure how to draw a diagram, draw it first and then check it with me. Okay. When you're ready for a diagram, you can press play. So here's the diagram. Okay, here's the diagram. So diagram is from A means a central point. When you measure the bearings always measure from north line clockwise. North line means you have to draw a north line and then go clockwise. So anything from there is clockwise. So 60 degree from A means you go clockwise 60 degrees. That's B, 8 kilometers. And C is 18 degree bearing from A. So from A again, 18 degrees. That's diagram. Okay. If you're unsure how to draw one, here we go. Right. Pause the video. Hurry and work on the answer. When you're ready for the answer, you can press play. Well, here's the answer. Quite straightforward. Once you've drawn a diagram, that angle will be 42 degree, not 60, because you have to do 60 minus 18, which is 42 degree. So the opposite to the length opposite to the angle will be A. So that's your x squared. So quite straightforward. Put the whole thing in calculator. Make sure calculating degrees. And then you should get square root 5.5 and round to 2 SF. Okay, let's move on. Sine rule. So A over sine A equals B over sine B. Now you might have learned about C over sine C as well equal. That's the whole sine rule, but that's not useful for us to solve the equation. To solve the equation, you only need 2 parts rather than 3 parts. So A over sine A equals B over sine B. Or sine A over A if you flip both fractions. The fraction on both sides. So well, which one do you use? Well, when? Well, if you want to find the length, you put a on top. If you want to find the angle, then you put sine A on top. Okay, then that way you don't always, then your variable is always on the numerator instead of denominator, which is a bit annoying to solve. So when to use it? Use it when a triangle is involved with two lengths and two angles. Remember cosine rule? Cosine rule is three lengths and an angle. Sine rule, two lengths, two angles. The A value is the length opposite to the angle A. We know that. Okay, so example in here, find the value of X. Now, X is a length. Therefore, I'm going to use A over sine A equals B over sine B, right? That's my A. That's my angle A. That's my length B. That's my angle B. So straightforwardly, X over sine 85 degree equals to B 8 over sine 45 degree. Okay, I'm going to multiply that denominator to right hand side, means X equals 8 over sine 45 degree times sine 85 degree. Okay, so put in a calculator, you should get 11.27 if I did it correctly in my head, of course. No, I'm just kidding, it's a calculator. Okay, right. So, yeah, if you're happy with it, again, your turn. Pause the video, have a go at the question. When you're ready for your answer, press play. Here's the answer. Well, make sure you don't use the wrong angle. X over sine 100 equals 8 over sine 30 because the 30 degrees is opposite to 8. So you shouldn't be using the 50 degree at all. Okay? Unless you use cosine rule, I guess. You can use cosine rule, but it'll be long-winded. So I'm not going to go for that. Right. Next one. Missing angle. So missing angle, same thing in here. That's time X. So this time, because the X is the angle, so I'm going to use the other version. Sine A over A equals sine B over B. So sine X degree equals over A over the length 5 over equals to sine 85 degree over sine over 6. Sorry, keep saying the wrong thing. The S and the 6 and the 5 looks too similar to me. Right, so to work out X, to make X subject, I will times by 5 on the right hand side first. So give it sine 85 over 6 times 5. Okay, and then I'll put it in a calculator, or maybe not if you would like to. Then you can arc sine the right hand side or inverse sine. Okay. Now this looks a bit clunky. I do not recommend student writing this out. Actually, what I would recommend student to do is I'll recommend student to put this in the calculator first. So what I'll recommend student to do is to put the sine 85 over 6 equals 5. So sine 85 over 6. Make sure times 5 in here. And then inverse sine that answer. You should get 56.11 degrees. So that's the answer. Okay. So pause the video. Your turn. Practice question 4. Pause the video. Have a go. When you're ready for the answer, you can press play. And here is the answer. Okay. Right. I leave it 3SF, 4SF, whichever one you prefer. 2DP, doesn't matter. Right. Next one. Example. Ambiguous case. Okay. Ambiguous case. In a triangle ABC, AB equals 4 centimeter, AC equals 3 centimeter, and the angle ABC equals 44 degree. Work out two possible values of the angle ACB. Now, if you could use your imagination a little bit, if you don't want to make a mess on your notes, have a separate paper. Can you try to draw, right, two separate? Can you draw two possible triangles, okay, for this scenario? Try draw two possible scenario for this triangle, okay, on a separate piece of paper, okay? Off you go. So here are two versions of it. Okay, why do we have two versions, you may ask? Because we don't know if X is an obtuse or acute angle. Now, if you have a look in here, I was told AB equals 4 centimeter. That's fine. AC equals 3 centimeter. Actually, this should be a tad shorter. Oh, that messed up my whole thing. All right, okay. I'll fix it on the go in here. Sorry about that. So it should be a bit shorter. Doesn't matter. So that's 44. And that's X in here, and that's C, and that's, yeah. Okay, so you can see still works. We don't know if X is not obtuse in here. So X is obtuse, X is acute. So we don't know which one is it, but they're both valid. So how do you work it out? Well, let's ignore this for now. Let's try work it out normally. So what do we do? Two lengths, 4, 3, 4, 3, two angles, 44 and X, therefore sine rule. When do we use cosine rule again? We use cosine rule when it comes to three lengths and one angle. Two lengths, two angles, sine rule. Okay, so in here you can see, so X is an angle, so sine X over 4 equals sine 44 over 3. Okay. Then sine x equals to sine 44 over 3 times it by 4. And then x equals to inverse sine of that thing on the top. Put in a calculator, you should get 67.9 degree. Let me double check in a calculator. Yep, that's right. Just put in a calculator. You should get 67.85, around 2.9. So this 67.9 degree obviously refers to acute angle in here. Okay, now what about obtuse angle? Even though this triangle is valid, how do we find the other angle? Now, this is where we have to use the sine graph you have learned from GCSE. Okay, so we'll go through this a bit more in the latest chapter 9.5, a bit of recap. But for now, when it comes to sine angle, you must remember the two, when it says two possible values, this is what we call the ambiguous case. So how do we do that? Let's draw a sine graph. Okay, so that's the sine graph. So that's the sine graph. Yes, the full name for SIN is SINE, sine. It's not a sin. It's a sin when you call sine a sin, right? Then you should go to church and confess. Right. So sine graph. So what does sine graph look like? Okay, sine graph looks like this: 90 degree, 180 degree, 270 degree. Now that's the shape, basic shape you should have learned in GCSE. That's the x and that's the y. It's bound between 1 and -1. Okay. Now, one thing we know about sine graph is that there's a little symmetry in the 90 degree and also a little symmetry in the 270 degree. Okay. That means now we've worked out 67.9 degree. So 67.9 degree is, let's say, is here. Okay. That's 67.9. Oops. So if we draw the line, up in here, then you can see there are actually two values. One in here, one in here. So what's the other value then? So this is the obtuse angle, the ambiguous case. Okay, so this is the obtuse angle. So how do you work it out? Well, we know this 67.9 degree. So therefore, using symmetry, this here is also 67.9 degree. So to work this out, I can do 180 degree minus 67.9 degree, which is 112.1 degree. Okay, so we'll go for a bit more later. So how do we work it out? How do we continue with the writing the solution? Well, so the other angle, so using symmetry, so we know x also equals to 180 degree minus 67.9 degree, which is 102.1 degree. So x equals to 67.9 or 112.1. Okay, degrees. Right, so that's how we use symmetry. Okay, for the ambiguous case. If you're happy with this, okay, can I ask you try to, okay, pause video, have a go at this question. Okay, when you're ready for the answer, is this ambiguous case? Theta. Yes, this ambiguous case. You might have two values of theta. So there are two values, okay, of theta. So pause video, have a go at the question. When you're ready for the answer, you can press play. Right, I made a mistake. There should be only one value of theta because theta is obtuse angle. Okay, so what we should do is, first of all, use sine rule. 10 over sine theta over 10 equals sine 20 over 5. Put in a calculator, you get theta equal 43.16 degree. But theta is obtuse, right? We can tell from the diagram. Therefore, we have to perform the ambiguous case method we just learned. So put in a graph using symmetry. It's 180 degree minus 43.16, which is 103.6 degree, which is the actual value of theta. So there's only one correct answer of theta, which is this one. And then if I want to work out the x value, I have to work out you can either use cosine rule or you can use, like what I did, a sine rule to work out the the alpha value first, the angle alpha, and then use sine rule, which I think will be easier than using a cosine rule because yeah. So alpha is 23.16 degree. Then in here, I can do x over sine alpha. So x over sine alpha equals 5 over sine 20. Or 10 over sine 103.6 degree. Put in calculator, both answers should yield you 5.75 centimeter. And that's the end of the video of the lesson.